Hi everyone, I'm Ricardo Vale and this is my final project for the discipline of image processing of MECAI. My project is titled Tactical and Match Information Extraction through Football Matches Frames. The main idea of this project relies on how technology is advancing in other areas of knowledge. Football is not an exception. So the idea was to bring a perspective of data analysis into football frames images, which would bring important tactical information for people who are trying to analyze these images. The main goal of this project is to get these frames from the matches and understand the number of players of each team that appear in that frame, in that situation of the match. So here is an example of the picture of the dataset we have. It doesn't change much than that. It's really an attack or defense situation where we have players displayed alongside the pitch, and the idea is to get the number of players of each team. In this example, we have 4 players in this white team, which is Northern Ireland, and Wales has 5 players displayed at the pitch. Referees, goalkeepers should be ignored for this analysis, mostly because wearing different color of suits of jerseys, so it would be more complex to understand this in these kind of frames. Another example of these images that I'll show will evidence the challenges we have with this image. This one, for example, it is a game that is being done by the day, so we have shadow influencing in the background of these players. In specific, this player here could be a problem if we get borders, because the background it is changing to the shadow. This player here downside, it will be a problem we will see later. So another example of these images is appearing here. Another problem that we could have, it is really the blur, because the camera is moving, the player is constructing really fast, so we could have some of the players really blurred on this situation. And we could also have players that are not appearing completely in the image, just as this one who's close to the advertising banner. So the idea is really to extract the information from these images despite all these challenges. Here is an example of image of this data set we could work. So the idea is to get the information, and it doesn't necessarily need to count that player as long as he's not appearing completely in the image, but this one in terms of illumination and in terms of noise or blur is really good to have this kind of analysis. So the dataset is composed by 50 of these images, where we have these frames and we want to analyze how many players they are displayed in the pitch. Here is an example, as I have shown before, this image where we have 4 players of the white team, 5 players of the red team. This work also has a count of the expected result for each of these images, and there are some of them that are not an exact number, because we want to get also players. We don't need necessarily to get players that are only appearing in part of the player in the frame. It would be difficult for the algorithm to understand if this could be counted as a player or not. So that's why some of the images are counting. For example, 1362 is counting 9 to 10 players, who's saying, hey, to me, the algorithm displaying 9 or 10, both of them could be right answers. So the first part of this project is really the pre-processing. As you can see, we are dealing with RGB images, and we need to turn these images into one single channel image. in terms of pixel information. I had two ways to follow through that. So the first one was to try to isolate one of the channels of the RGB to see if we could get a better understanding of the image without losing any kind of information. And in this example, it could be seen that this is not the case. As we could see here, um, having only the red color channel, it would help us to understand if the players of the red team would be better identified, but as long as white has also the red channel in its most, it will actually be more confusing because some of the players of opposite teams they are looking like players of the same team in this channel, and we could also think about the player that is in the shadow point of the grass. He is almost becoming a blur. I made a test also for green and for blue, but it will be easier to work with the grayscale. And as you can see here, it would provide us a better experience trying to branching the image. Talking about branching the image, that's just the next step. Um, Create not necessarily bounding boxes, but sections of the images that could be considered bounding boxes, but they are not, as long as um, they are not showing borders. They are actually being really sections of these images. So the main idea is to use these sections of the images to isolate players in one of them. And the strategy due to that is really to apply a bag of features, and we could have some textures, some of the patches that could really give us a piece of the image when we have only one player and we could count it for a team or for another. So here is an example of this branching of the image. Here's one section where we could get exactly a player in this exact piece of the image. Making a division by these patches, we could get approximately 119 patches. So the idea of applying the bag of features is really to get information from these texts. We will assume that the players would have borders, and we could see that to apply a binary operation with the local binary patterns, just to be used the descriptors in this work. The idea of applying the LBP is really to get the patches converted and to apply a clusterization algorithm. We could get details of how these patches are being grouped. If we see this image, we could see that some of the regions are quite good separatedly. If we could get like a separation of the regions with that, but not necessarily it is good because there is interpolation of some clusters to each other. So we divided the images into 35 images of train and 15 images that will be used as test. So the entire process of the bag of features is applied. We get the image features, the test image features, and we get also the train image features, and we propose a comparison for them to understand how close the test images are from the train images. This was the first intention of the study. The desired results were really to get the number of players in the pitch, but seeing these results and seeing the application of bag of features, I could conclude that it would be better to try a different approach. I would try to compare images with the same number of players and check if the information is going to be brought by the way in which the most similar image that will be displayed with the train set it is the image of the test set that is most likely to have the same number of players in the pitch in that frame than the ones that have been selected in the train set. So the train set will be reduced and the test set will be the same, and we are going to compare the image features of only these images of the train set, and this is the image of the test set where we want to be the most similar to this subset of a train, because this image has 14 players and all of the images selected to this subset of the train set, they also have 14 players. So the idea of making the comparison of the entire test set with this subset of the train set is really to have this image of the test set to be selected as the most similar than the ones in the train set. And applying the same steps, it is really what we get. It is from the test set the most similar image from the ones in the train set that have 14 players as well. The conclusions is that the bag of features doesn't necessarily work good and conclusive to get the amount of players in the pitch, but it could be really good to compare same tactical informations from different frames from different games. So that's it, and if you have any questions you can comment below, and thank you for watching until now.